My dear students, in the previous video, I derived the derivative of the trigonometric function sin x by using the first principle under the exercise 13.2. Now in this video, I am going to find out the derivative of cos x from the first principle. Further, consider the function y equal to some y equal to cos x, y or otherwise f of x. F of x equal to cos x. By definition of derivative by dx, derivative of x, limit x tends to 0, f of x plus h minus f of x divided by h is a fundamental definition of the derivative of a function. Here f of x is cos x, therefore dy by dx is limit h tends to 0, cos of x plus h minus f of x is cos x divided by h. And in the next step, cos x minus cos y. Using the trigonometric idea, cos x minus cos y is minus 2 sin x plus y by 2 into sin x minus y by 2. Using that idea, cos x plus x minus cos x, this is cos x minus cos y, is minus 2 sin x plus x by 2 into sin x plus x minus x by 2. Minus 2 sin x plus y by 2 into sin x minus y by 2. Using that idea and denominator h. So limit x tends to 0 minus 2 sin of 2x plus x by 2 into sin x plus x minus x cancel, you will get only h by 2. The whole divided by h. Again you bring this numerator of h to the denominator to the denominator. The next step. That is you split the limit into two limits, that is equal to dy by dx in the left hand side equal to limit h tends to 0 minus sin of 2x plus h by 2 minus sin of 2h plus h by 2. Again into limit, you split the limit into two limits, limit x tends to 0 sin h by 2, the whole divided by h, you take it to the denominator of sin h by 2 and bring this numerator 2 to the denominator, h by 2. So, I bring this numerator 2 to the denominator, that is h by 2, and consider it as a separate limit h tends to 0 sin h by 2 by h by 2. By applying the limit now, h tends to 0 implies minus sin 2x by 2 only into limit h tends to 0 sin h by 2 by h by 2 is 1 by definition. Therefore, 2 to cancel, this is minus sin x. So, derivative of cos x is minus sin x. Yesterday, in the previous video, we have seen that the derivative of sin x is cos x. The second one, derivative of cos x is minus sin x. This is our next idea. So derivative of cos x with respect to x by the first principle formula is minus sin x. You consider this as another state. Derivative of cos x. So sin x is, derivative of sin x is cos x and derivative of cos x is minus sin x. Next, I will consider, we have to find out the derivative of tan x from the first principle. It is in the example. Now from the example I am going to solve. Find the derivative of tan x from the first principle. That is our idea. Find the derivative of tan x from the first principle. You consider the given function f of x as tan x and apply the same idea, first principle idea definition, and using that idea we are going to find out the derivative of tan x. That is our next problem. Consider y or f of x is tan x, f dash of x is nothing but dy by dx. By the definition it is limit h tends to 0 by definition of the limit f of x plus h minus f of x by h. This is equal to limit h tends to 0. Tan x is f of x, therefore tan of x plus h minus f of x is tan x by h. This is our idea, and you know that limit h tends to 0. Tan x is sin x by cos x, therefore I can write this tan x plus h by sin x plus h by cos x plus h minus tan x by sin x by cos x, the whole divided by the given h. Now you consider the numerator, taking LCM as cos x plus h and cos x, you will write limit h tends to 0, denominator you have h, numerator you have one as LCM cos x plus h into cos x. If you take LCM as cos x plus h into cos x, this is sin x plus h into cos x. Sin x plus h into cos x minus, by taking LCM, cos x plus h into sin x. This is the idea. After taking LCM in the numerator as cos x plus h and cos x, we will get sin x plus h into cos x minus cos x plus sin x divided by cos x plus h into cos x as LCM. The whole denominator is divided by h, which is again already we have it in the denominator h. You know sin a cos b minus cos a sin b formula. Sin a cos b minus cos a sin b. You know that one trigonometric result. Sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b is sin a minus b. Sin a cos b minus cos a sin b. You know the result as sin a minus b. Therefore, the numerator is, I am going to write here derivative of tan x by using the first principle. This is dy by dx. In the left hand side is limit h tends to 0. Sin a cos b minus cos a sin b is sin a minus b, that is x plus h is a minus x is b. Sin a cos b minus cos a sin b is sin a minus b. Sin x plus h minus x, because this is a, this is b. Sin a cos b minus cos a sin b is sin a minus b, that is sin x plus h minus x. The whole divided by, you bring this cos x plus h into cos x to the denominator. Already you have one h in the denominator. Now, again, I bring this term numerator denominator to the denominator as cos x plus h into cos x into the already h. Now, limit h tends to 0. This is plus x minus h cancel. You will get sin h, and you consider this h here. You consider this h sin h by h, and again you split as a limit h tends to 0 into two limit 1 by the term is sin h by h is here, and 1 by cos x plus h into cos x. You have cos x plus h into cos x. Now apply the limit. Limit x tends to 0 sin h by h is 1, you know. This is 1. And the limit x tends to 0, 1 by, if x tends to 0, you get cos x. Since h is 0, you get cos x into again 1 cos x. Therefore, this is 1 by cos square x. This is 1 by cos square x. So dy by dx is, derivative of tan x is 1 by cos square x, or nothing but 1 by cos is secant. Therefore, this is secant square x. 1 by cos is secant, by trigonometry this is secant square x. So derivative of tan x is secant square x. D by dx of tan x is secant square x. That's our result. This is another derivative of tan x from the first order. Now we have derived three results. 1. D by dx of sin x is cos x, and 2. D by dx of cos x is minus sin x. Just we have seen. Third one, d by dx, that means derivative of tan x is secant square x. So using this idea, I am going to differentiate another three trigonometric results, that is cosecant, secant, cot. The reciprocals of sine, cos and tan I am going to find out. We have to find out the derivative of cosecant x now. Find the derivative of cosecant x. It is not by the first principle, it is by using the differentiation rules. Find the derivative of cosecant x. You consider y equal to cosecant x. This is actually given in your exercise as 11th problem, third subdivision. Sorry, fourth cosecant x. Derivative of cosecant x is given as 11th sum, fourth subdivision. Find the derivative of cosecant x. So you know cosecant x is to know 1 by sin x, because sin x reciprocal is cosecant. Reciprocal of sin x is cosecant. By using the quotient rule, dy by dx equal to denominator square d square v into d by dx of u is 1, minus u into d by dx of v is sin x. This is idea. Now that's equal to derivative of 1 is 0. So in the numerator we get sin x into 0 minus 1 into derivative of sin x is cos x by sin square x. So 0 into sin x is 0. You get minus cos x by sin square x. I can write it as sin x into sin x. That is minus, I split this as 1 by sin x into cos x by sin x. So I split this sin square x as sin x into sin x, and I split into two functions, that is minus cos x by minus 1 by sin x and into cos x by sin x. Because minus sin x is minus 1 by sin x is cosecant x and cos by sin is cot x. So derivative of cosecant x is this. Derivative of cosecant x is minus cosecant x cot x. That's all about this. Derivative of cosecant x is minus cosecant x cot x. Similarly, find the derivative of secant x. That's also in your exercise problem 11, second subdivision. Find the derivative of secant x. You consider the function y equal to secant x. As in the previous case, y equal to 1 by secant x 1 by cos. Same idea. dy by dx equal to b square cos square x into cos x into d by dx of 1 minus 1 into d by dx of b cos x. So similarly, in the cos x into derivative of 1 is 0 minus derivative of cos x is minus sin x by cos square x. Here also cos x into 0 is 0, minus plus sin x. As in the previous case, I can split cos square x into cos x into cos x. I split the cos square x by cos x into cos x. Therefore, once again you write it as 1 by cos x into sin x by cos x. That is equal to 1 by cos x is secant x into sin by cos is tan x. Secant x tan x. So d by dx of secant x is d by dx of secant x is secant x tan x. This is another result. This is also given in your problem 11, subdivision 2. Subdivision 3 is cosecant x, subdivision 2 is secant x. And one more thing I am going to derive, find derivative of cot x. If I derive the cot x and all the 6 trigonometric results we have derived. Okay. Now, find the derivative of cot x. That's our next idea. Find the derivative of cot x. Derivative of cot x. You consider the function y as cot x, and cot x you can write as cos x by sin x. This is y. Cot x can be expressed as cos by sin. Again by quotient rule, dy by dx equal to denominator square sin square x into denominator sin x into d by dx of numerator cos x minus numerator cos x into d by dx of denominator function sin x. V square v into du minus u into d. Quotient rule. Denominator v square v into du by dx minus u into dv by dx. Using the quotient rule idea, this is sin x into derivative of cos x is minus sin x. You know the result of cos x minus sin x. Minus cos x into derivative of sin x, you know cos x. By sin square x. Derivative of sin x, this is, what is that? Sin x into sin x is minus sin square x. Minus cos x into cos x is cos square x by sin square x. That is, you can take minus cos common term, you get minus sin square x plus cos square x. If you take minus in both the terms, I will get sin square x plus cos square x by sin square x. So now sin square x plus cos square x is 1. 1 into minus 1 is minus 1 by sin square x. Minus 1 by sin square. You know 1 by sin square is cosecant. Therefore this is minus cosecant square x. Therefore d by dx of cot x is minus cosecant square x. So all the 6 trigonometric results have been derived. Already we derived the derivative of sin x is cos x, and derivative of cos x is minus sin x, derivative of tan x is cosecant square x. Now we derived derivative of secant x is minus secant x tan x, derivative of secant x is secant x tan x, and derivative of cosecant x is minus cosecant x into cot x, and the derivative of cot x is minus cosecant square x. You just write those 3 results. Totally 6 trigonometric functions. I have differentiated all the 6 trigonometric functions we have derived. See, we have differentiated all the 6 trigonometric functions. Already we derived 3. Next, fourth one, d by dx of cosecant x is minus cosecant x into cot x. Fifth one, d by dx of secant x is secant x into tan x. And sixth one, d by dx of cot x is minus cosecant square x. So all the 6 trigonometric results we have differentiated, and I will stop this video here, and the remaining problems I will continue in the next video. Thank you.